Heavy metal pollutants often find their way into water bodies and sediments, either from natural geological sources or anthropogenic sources. Their presence in water bodies can be detrimental to the aquatic ecosystem and upstream food chains. The Seomjin River Basin, or SRB, in South Korea passes through steep mountains and abandoned mines, and may therefore be a source of heavy metal pollutants. Researchers from the National Institute of Environmental Research, South Korea, collected surface sediment from the Seomjin and Basin rivers in the SRB and confirmed the distribution and characteristics of pollutants using particle size assessment, heavy metal concentration analysis, and sequential extraction. Their analysis revealed that sand was the prevalent particle, accounting for greater than 70% of surface sediments. Further, while the mean concentrations of lead, zinc, cadmium, and mercury were similar across the Seomjin and Basin rivers, those of copper, arsenic, chromium, and nickel were 1.5 to 2-fold higher in the Basin River and were associated with geological rather than anthropogenic sources. Comparison with sediment quality guidelines nonetheless suggested that these concentrations did not indicate serious pollution, although arsenic and nickel levels were found to be potentially toxic to benthos or aquatic organisms in the Basin. Further analysis of the eluted fractions suggested that the availability and mobility of heavy metals was the highest for lead and cadmium, and the lowest for chromium and nickel, as they were strongly bound to lattices in the sediments. Moreover, while cadmium and lead showed the highest risk level to benthos, their concentrations were lower than those of chromium and nickel, which had relatively lower risk levels. Overall, these findings suggest that although the concentrations of heavy metal pollutants in the SRB may not be alarming currently, they can become a cause of concern and must therefore be regularly monitored.